elements are the set members, of course. How it empty set as this empty set as this no zero zero. Unbounded set. Set is a collection of objects. We know that set of collection of objects, but unbounded भनेको के भन्ने question आउला. A bounded set is the one, or any bounded functions is the one that has some sort of upper limit or lower limit. Maybe a is less than or equal to b छ भने अथवा a is less than or equal to 10, or maybe a is greater than or equal to minus 10, something as such. So unbounded set like represent गर्छ. Set, we represent this unbounded set using but then using this binary search tree. Binary tree र binary search tree, these are two different things. हामी यहाँ BST को कुरा गरिरहेको छौँ. BST र BT मा चाहिँ if you are confused, visit the previous slides, previous recordings. So then set represent गरिरहेको छ. It represents the set using CA, MX र US भन्ने. Canada, Mexico or US, maybe something as such. Set represent गरिरहेको छ. These three countries. And then you can see that the representation of a set is not unique here. Unique चाहिँ हुँदैन. It's not unique. Might be different. Start from जुन पनि हुन सक्छ यसरी. There's not one fixed order to represent the set. And then that's pretty much all that this slides actually tell about some representation of set using BST. Set, again, order of elements. जसरी हामीले अघि एलिमेन्टहरु राखेको थियो त्यसरी चाहिँ एउटा एलिमेन्टहरुमा सेटको आइटम्सहरु राखेर we are trying to represent the binary search tree here. Three operations: contains, add, and remove, aimed at searching, insertion, and deletion. Given has both of them. All of these three have their best and worst time complexities. They have their best and worst time complexities. So these time complexities are dependent on the nature of the binary search tree that we have. Would anyone like to explain or discuss the time complexity? By now, you should be able to discuss the time complexity. In what case it becomes the best? In what case it becomes the worst? Given it's a binary search tree. Would anyone like to explain this to your class? Would anyone like to explain this to your class? Still less number of people, only 25. Okay. Okay, so best case happens when a binary search tree, when the degree of the balanced or the nature of the binary search tree is inclined towards being more balanced or well balanced. Well balanced tree, my time complexity becomes of order. The time complexity goes, it is inclinated towards this logarithmic order. But then in worst case, those are of that of a binary search tree that is ill balanced. In those instances, these worst case time complexity will occur in different conditions such as search, insertion, different operations such as contains, add, and remove here. Okay, so binary search tree, best case is log n, and then the worst case is of linear order, and the real life somewhere in between here, the binary search tree, the design which is more inclined towards more well balanced, gives us the best. The result is more inclined towards the best scenario, and then the one that's not, it's more inclined towards the ones that are ill balanced, they inclined to be to give this worst case scenario to us, which is of a linear order. Okay, so again I'll ask it again. Just like the ones that had constructed three binary search trees and had some problem of doing the traversal, please let me know. Doing the in order traversal to find out if it's ascending order or not, and also some of us bonus they had done that pre and post order पनि गर्नु भएको थियो. तपाईहरुले त्यसमा पनि कुनै प्रब्लम छ गर्नु भएकोहरुलाई भने please let me know. Otherwise I'll start the next chapter, that is graph. graph core theory, or we'll talk about it. Okay, so then for now, okay, there's some message. Okay, so he's not in the class currently. Okay. So I do remember the class when I pitched this question to you. What data structure does Facebook make use of? And then the answer came around someone in this class. You said it was graph. So that's what we're going to talk about, graph ADTs. We'll be going through the graph concepts, applications. We'll just go through this requirement and contract that's given in this presentation here, in this PPT here. So graph concept, we'll go through this, applications, we'll go through it, and then graph ADT, right? Or graph ADT. I'm sure that most of you know the meaning of this, but so that so for the sake of this suppose entirety, for the sake of entirety, I'll just tell again. Graph ADT requirements and contract. So जतिवटा धेरै रिक्वायरमेन्ट जतिवटा धेरै डिफ्रेन्ट कन्ट्र्याक्टहरू भयो त्यही अनुसारले ग्राफ एडिटीको नेचर पनि चेन्ज हुन्छ सो अमङ so many of it we are going to discuss this one even that we are going to discuss surfacely because most of it is in Java but we'll see ADT data to implement ADT data structure what do we need to do one day we'll see we'll talk about up to here it's set representation but then I'll leave you with something that you need to discuss or you need to brainstorm and we'll need to discuss in the next class. So, graph. To do this, I need to get one graph image. Okay, this one's good. Okay. The basic terms. A graph is a collection of nodes and edges. Nodes, they have elements. Okay, nodes are also called as vertexes. Vertex. Or this collection of nodes are called as vertices. So one of anyone, I guess that way the class you understand, but someone who I haven't talked to yet, or I don't evidently remember. Okay, Apeksha. Yes, please unmute. Please have it on unmute and let's discuss this. So this is a graph. How it becomes a graph is that it has a collection of nodes. These nodes here contain the element A, B, and C, and then these have the edges here. Okay, but even then, this one's also It has something extra, so let me find one. And then we'll discuss that structure. Yes, this would be perfect for our use for current use. So Apexa, we are talking about graphs. These these are the nodes here. The ones that you see in the circle A, B to F here are the nodes here. Okay, it contains the elements A to F in the current case, and the edges are these connections. A to C, you line the here on. So these are the edges here.
Yes, sir.
Each node, or maybe you can call it as element. Each node has element. Sometimes it called as element also. But node like vertex one once, okay? Vertex or edge one there's in practice. Mostly US language, US websites are mostly vertex one rounds. Okay, vertex and edge one at the rounds. It contains an element. This node here contains the element A. This node here contains the element D. This node here contains the element E. This node here contains the element B. Each edge contains two nodes. Each edge or arc, one is a edge. This one here, or this one here, or this lines here, they just basically connect the two together. Okay, so edge, node, graph, any element, vertex, and arc, all of these terms are clear. Okay, that's how clear by Apexa. Is it fine
Okay.
so far?
Yes.
And edge has an optional edge attribute बनेगा. So edge attribute के बारे में से we'll talk about this. Okay, we'll talk about this. But edge attribute means some property of the edge, some property of the edge. So let's say A is a city and B is another city. This could be the road, the distance, the the roadway distance from A to B. So that would be an edge attribute. Something that is related to the edge is a edge attribute. It might be the number of hours from number of hours it takes to fly from a city A or a city B to C. Okay, so two nodes are neighbors. So two nodes are neighbors if they are connected by an edge. Okay, two nodes are, so they are connected by an edge. So A is the neighbor of B, C is also the neighbor of B, and E is also the neighbor of B. The degree of a node is the number of connecting edges. The degree of a node is the number of connecting edges. Okay, so let's say A is for Apexa, C is for Chandan. I guess he is in this class. Division, right? So let's talk about these three. So and uh, and let's say this node E is for Rahul here, and so if it were a let's say it were a basic some social networking thing. So A is friends too. So this neighbor term you could replace it with friends. You could replace it with the word friends, and then if you have to get to E, A cannot directly, Apexa cannot directly get to Rahul, but she can get through Rahul, get to Rahul through division here. Okay, so basically that. So basically, if you need to get to some city F, then you need to first visit the city D, or maybe you could visit the city B first, and then you could go to E, and then to D, and then to F. Correct? The degree of a node is the number of connecting edges. So Apexa, up to here, is it clear?
Yes, sir.
Okay, so these are the basic terminologies. So how many nodes are there in this graph, Apexa?
6.
Six. So what is the size of this graph?
Size.
Yeah, size. The size of this graph is the number of the nodes, that is, according to you, 6, right? Size of this graph will be 6. If it had no nodes, then it would have been an empty graph. Sorry. All right, Apexa, thank you. Uh, I'll call someone else now. Suraj Garti. Mr. Suraj. Mr. Suraj. Okay. I'll keep his name here so that I can use it for later reference. If you have a mic problem, send a message. Suyog.
Yes, sir.
Okay, let's discuss undirected and directed. Since you are here, please be with me and let's discuss this. So, अहिलेसम्मको बुझ्नुभयो basic terminology related to graph. Yes or no?
No, sir.
No. Which one have you not understood? You blue color भएको हेर्नुहोस्. Or were you not present in the class? All right, Smriti Shrestha,
Yes, sir.
यो टर्मिनोलोजिजहरु बुझिराखेको छ?
बुझेको छ sir.
बुझेको छ. Okay, then help me with this. So this point here, please read it out.
An unidirected graph is one in which
Undirected
edge
graph. Undirected graph.
graph is one in which edge has no direction.
And then the after that, the one after that.
A directed graph or digraph is one in which
Digraph.
each edge has a direction.
So in this graph that you see on the right of the screen, is it a undirected graph or this is a directed graph? So see the edge first, right? Edge को direction छ कि छैन? Edge are these connections. So do the edge have a direction?
Oh, yes.
Yes. So what is the direction of this edge? C र B मा भएको edge चाहिँ कुन direction मा छ? C to B छ कि B to C छ?
China say
So this is undirected or this is directed?
undirected.
Okay, and what would you call this graph here? Is this undirected or directed?
Directed.
Because the edges have a
Because
direction. So this edge 4 here, or maybe it's some attribute of the edge. What is the direction? Is it from A to B or B to A?
A to B.
A to B. All right. Okay. I think there's some lack of confidence in your voice, and I might be wrong, but if that is so, there's no need to worry. Okay, please do not worry. तपाईहरुले राम्रोसँग सिक्नुहोस्. एकजनालाई मैले भनेर मात्र तपाईलाई बोलाएको. I don't want to intimidate you. All right. So please don't worry. Firstly, take a deep breath and be a little loud. All right.
Yes, sir.
Okay. So it talks about this directed graph here. So let's talk about this graph. V is the source of E and W is the destination of E. So in the case of this graph, and while you consider A and C, which one is the source and which one is the destination?
A is the source and C is destination.
And C is the direction, right? That
Yes.
was, who was that? That was Apeksha. No problem if someone wants to participate. Smriti can give them the turn, but and then you buzio, Smriti?
Yes,
Source
sir.
and destination. Okay. Okay, who was that? Fairy Bolno boy. I'll give them the opportunity. Smriti and okay. So source and destination बुझ्नु भयो है स्मृति?
Yes, sir.
सो सोर्स र डेस्टिनेसन बुझिसके पछाडि के हुन्छ भने इन एज र आउट एज भन्ने हुन्छ ओके सो फर सी दिस एज 7 इज अ इन एज है टुवर्ड्स सी छ सी लाई डेस्टिनेसन बनाएको छ सी नोडलाई डेस्टिनेसन बनाएको छ सी एलिमेन्ट भएको नोडलाई डेस्टिनेसन बनाएको छ एन्ड देन आउट एज भनेको चाहिँ समथिङ द्याट इज पोइन्टिङ आउट अफ दिस यसलाई चाहिँ सोर्स बनाइएको छ जसको माध्यमबाट सो दिस वान दिस एज विथ दिस एट्रिब्युट 2 with this attribute 2 is a in edge of C, sorry, out edge of C, but then this is the in edge. Okay. बुझ्यो in edge र out edge भनेको inside र outside गए जस्तो अथवा towards or outwards. W is a
सुनिरहेको छैन
राम्रो आइरहेको छैन okay no problem then I'll pick someone else Meghant
yes sir
okay ल सोर्स डेस्टिनेसन बुझ्नु भयो है
बुझे सर
इन एज र आउट एज नि
त्यो नि बुझे
बुझ्नु भयो हैन र सक्सेसर र प्रिडेसेसर what is the predecessor of C here
A
and B both
A yes
right?
yes
Yes okay and then the in degree and out degree of the in degree of a node is the number of in edges the out degree of a node is the number of out edges so what is the in degree of this node C here in degree of the node C here
3
and what is the out degree of the node C here
1
1 okay so a path and a cycle a path is a list of nodes such that each node and its successor in the list are connected by an edge भनेर भनिएको छ okay is a list of nodes भनेछ such that each node and its successor in the list are connected by an edge भनेर भनिएको छ so this one is a path from C to B correct यो एउटा path भयो complete यो edge भयो के रे नोड अथवा एज अनि यो जुन
Sir,
this हजुर
excuse me, sir.
yes please
Sir, I didn't get in degree and out degree, sir.
out degree बुझ्नु भएन in degree बुझ्नु भएन okay
Sir,
so
in degree
I
and out
yes
degree.
okay Megan please mute your mic Janice please keep it on mute all right हामी फेरि कुरा गरौँ
Okay, sir.
so in a directed graph हैन in a directed graph यो directed graph हो भन्ने कुरा बुझिएको छ एज को डाइरेक्सनहरु छ यसमा तपाईले सोर्स र डेस्टिनेसन बुझ्नु भयो सोर्स भनेको चाहिँ ए एउटा सोर्स बी इज द डेस्टिनेसन हियर
Yes.
and this this is attribute this edge here we have a edge this might be the name of the edge or this might be the attribute of the edge maybe the distance okay
Yes.
so successor र predecessor पनि बुझ्नु भयो
Yes, sir.
सक्सेसर प्रिडेसेसर पनि बुझ्यो इन एज र आउट एज चाहिँ बुझ्नु भएको छ कि छैन
Image is image of W and outage is of P. No, sir, I think.
सो यसमा चाहिँ यो भी र मैले ठ्याक्कै यसलाई कन्स्ट्रक्ट गर्नुपर्ने सपोज दिस इज भी है यो सोर्स भयो हैन सोर्स
Yes, sir.
हैन यो भी भयो अनि डब्लु यो भयो रे है यो
Yes, sir.
डब्लु भयो एन्ड दिस इज द एज इज नेम इज ई ओके सो सोर्स डेस्टिनेसन ई भयो हैन बुझ्नुभयो सो ई इज एन इमेज अफ डब्लु एन्ड भी इज द आउटेज अफ भी भनेर भनिएको छ सो जुन चाहिँ तपाईँले यसलाई जस्तै त यसको तिर आएको छ यसबाट बाहिर गएको छ नि हेर्नुहोस्
Yes, sir.
यसबाट यता यसमा गएको छ सो दिस इज द इनेज फर ए बट दिस इज द आउटेज फर सरी दिस इज द म फेरि भन्छु
No.
आई एम सरी द्याट आई हेड यु कन्फ्युज सो यो एज छ नि जुन बाहिर गएको छ हो यसलाई आउटेज भनिन्छ क्या एमा एबाट
Yes, sir.
तीनटा आउटेज छ ओके तीनटा आउटेज छ तीनवटा चाहिँ एउटा ए चाहिँ तीनटाको सोर्स भएको छ क्या अहिले हो
Eh,
ए चाहिँ तीनटाको सोर्स
sir.
भएको छ सो द्याट इज द नम्बर अफ इमेज अनि त्यही तपाईँको सपोज बीमा यदि आयो भने चाहिँ बीमा चाहिँ बी चाहिँ के को डेस्टिनेसन भएको छ ए को डेस्टिनेसन भएको छ सी को डेस्टिनेसन भएको छ बाई द भर्च्यु अफ दिस टु एजेस which has the attribute which has value 4 and 2 हो
So, भनेपछि B को चाहिँ outage A र C.
बी आउटेज होइन त्यो त सोर्स र डेस्टिनेसन भयो आउटेज चाहिँ यो 4 बी को आउटेज चाहिँ 5 भयो के बी बाट बाहिर गइरहेको जुन यो छ नि हो अनि यो जुन 4 र 2 छ नि यो बी को इमेज भयो ओके सो इन डिग्री र आउट डिग्री भनेको चाहिँ त्यसैको काउन्ट हो इन डिग्री इज द नम्बर अफ इमेजेस एन्ड आउट डिग्री इज द नम्बर अफ द आउटेजेस हो सो बीलाई हेरौँ अथवा मेबी ल एलाई हेरौँ वाट इज द नम्बर अफ इन डिग्री अफ ए इन डिग्री अफ नोड ए कति हुन्छ त
So 0. I don't think
0 एन्ड आउट डिग्री कति हुन्छ
Out degree 3.
3 ओके थ्याङ्क यू सो त्यति नै हो है अब तपाईँ नै हुनुहुन्छ प्लिज बी कन्टिन्यू नै गरौँ पाथ भनेको छ a list of nodes such that each node and its successor in the list are connected by an edge भनेर भनेको छ सो दिस इज अ पाथ यो एउटा यो एज अनि यो नोड अथवा यो दिस टु भर्टिसेसलाई लिए भने एउटा पाथ बनेको छ पाथ फ्रम ए टु बी ओके अ साइकल इज अ पाथ हुज फर्स्ट एन्ड नोड लास्ट आर द सेम सो यो एउटा साइकल हुन्छ ए टु बी बी टु सी एन्ड सी टु यो चाहिँ छैन रहेछ इट्स नट देयर बट if there were if a were the destination of the source C it would have been a path है घुमेर त्यसमै आएको हुन्थ्यो साइकल भनेको त्यही रिभिजिट हुनेलाई चाहिँ भनिन्छ लेट मी टेक अनदर वान हियर देन यसलाई नलिउँ यसलाई लिउँ सो 1 बाट स्टार्ट भएर ओके 3 मा आयो 3 बाट 2 2 बाट 4 4 बाट 1 भने दिस इज अ साइकल हियर है फर्स्ट र लास्ट नोड सेम हुन्छ र साइकलमा मेक नोट द्याट यो 1 फेरि बिचमा चाहिँ आएको हुनु हुँदैन है द्याट वुड बी 2 साइकल्स अनि एसाइक्लिक ग्राफ भनेको के हो एसाइक्लिक ग्राफ भनेको के हो द वान द्याट कन्टेन्स नो साइकल सच एज दिस वान यसमा एउटा साइकल नै छैन एबाट स्टार्ट भयो भने एमा आउँदैन बीबाट स्टार्ट भयो भने पनि बीमा आउँदैन सीबाट स्टार्ट भयो भने चाहिँ इज देयर अ वे नो देयर इज नो सो दिस इज अ एसाइक्लिक ग्राफ साइकल छैन तर पाथहरू चाहिँ देयर आर मेनी पाथ्स हियर 1 2 3 4 5 एन्ड देन मेबी द कम्बिनेसन अफ दोज हो सो दिज आर द बेसिक्स अफ your ग्राफको टर्मिनोलोजिजहरू आई होप द्याट्स क्लियर नाउ The applications of graph, how it's used is that maybe there are different cities, and let's consider the cities of Nepal, Kathmandu, Pokhara, and then maybe you can come to Bharatpur, maybe you can come to Bhairava, or maybe you could go as far as Yatauda, and then to Birganj, Viratnagar, Damak, or maybe you could go up to Mahendranagar or Dhangadi. So a road network is a graph whose nodes are cities and whose edges are the roads connecting these cities. Maybe the distance from one city to another, the road distance could be one attribute. So the edge attributes are typically distances. So road network money we could have this problem solved. Okay, and then if you could consider a cycle, Kathmandu bada चाहिँ नारायणगढको बाटोबाट सरी लेट्स से काठमाडौँबाट चाहिँ तपाईँ उता सिन्धुलीतिरबाट चाहिँ नारायणघाट आएर फेरि बुटोल आएर बुटोलबाट पाल्पा गएर पाल्पाबाट पोखरा एन्ड देन ब्याक टु द्याट वुड बी वान साइकल ओके द्याट वुड बी वान साइकल सो अ रोड नेटवर्क इज अ ग्राफ which contains nodes and cities which contains nodes in forms of cities and then edges in forms of roads. The pipeline network, maybe the pipeline network of Melamsi, you could say pumping stations and those whose edges are pipeline connecting them. An activity chart may mostly used in project management. Which activity do we need to finish first? Which activity we need to finish? We need to do after completion of some certain activities. Activity chart le bhancha. Maybe there is someone who plays American football, or maybe there is someone who plays cricket. There are equipments that he need to or he needs to use. So activity chart ma chai testo kuraharu aउँछ. Sorry. समर्पण माइक अन म्युटमै राख्नुहोस् है अहिलेलाई ओके थ्याङ्क यू लेस पिपल इन दिस क्लास So this is the road network. So this would so the shortest path find गर्नु पर्यो भने let's go from London to Manchester. Let's go from London to Manchester. You could go to Rugby and then Leeds and then to Manchester, but or maybe you could go to Birmingham and then to Manchester directly. Okay, but then the shortest would be this distance from Manchester, Birmingham, London would be 280, but then 150, 170, and then 70 would give you 390. So this would be short, right? You would choose this network to get from London to Manchester. It says that these are the example paths, but these are not the example path because there is something here missing. If you see this, if you examine this graph correctly, you port border up to this location, they said it has no path because it has missing Edinburgh miss bhaइरहेको छ त्यसमा, right? This node is missing there. So it shortest path भन्ने, there's this problem here, shortest path, find the shortest path भन्ने problem हुन्छ, and it makes use of graph. It's even there in तपाईहरुको AI मा पढ्ने बेलामा पनि shortest pathहरुको प्रब्लमहरु आउँछ, shortest path. So this is solved by the use of graph. So activity chart would be something as such. So Samarpan, would this be a acyclic graph or a cyclic graph? Would this be a cyclic graph or acyclic graph? यो जुन छ नि चार्ट तपाईले हेर्नु भएको छ, this is also a graph, yes, and this is a directed graph. So is this acyclic or is this not acyclic? हजुर अलि ठुलो स्वरमा भन्नुस् न, डोन्ट वरी. फेरि भन्नु है, बुझिएन. Acyclic. Okay, mic मा अलि प्रब्लम छ जस्तो छ, त्यसलाई बनाउनु होला. So this is acyclic graph because it contains no cycle, एउटा cycle छैन यसमा. Okay. So then there's this graph ADT that this I discussed, and these are the possible requirements. The contract includes these 8 requirements. This one is only for a directed graph. It must be possible to make a graph empty. It must be possible to add a new node or add a new edge connecting 2 existing nodes to a graph. It must be possible to remove a node or to remove a given edge. It must be possible to test whether a graph has an edge connecting 2 given nodes. Must be possible to access all nodes or edges of a graph. It must be possible to access all neighbors or all connecting edges of a given node in a graph. It must be possible to inspect or update the element contained in a given node. And for a directed graph, it must be, according to this contract here, the requirement 8 says for a directed graph that it must be possible to access all successors or all out edges of a given node in a directed graph. So I'll give you 2 minutes, 2 minutes. I'll give you 2 minutes. I'll give you 2 minutes to read these and then understand these. Okay. This is the possible operations or maybe the possible transformer, mutators, or constructors that you need to construct to make implementation of this graph. So if there's any term, I guess there's no term that you do not understand in this, but if there is any, please do let me know. I'll give you this for 2 minutes. I'll give 2 minutes time for you to read this and also understand. All right. These requirements, do they make sense? Do they make sense? If not, please tell the requirement number. Please tell the requirement number, and maybe we could discuss it what it means. But the implementation part is yet to be done. So these are the requirements. So this is what these are the different possible, possible requirements that a graph ADT contract might have. More or less, so it might have something in top also. So uh, something on top as well, but this one is for a directed graph only. So let's see how it has made use of constructors, mutators, and iterators, transformers to implement this. But then it hasn't.
Sir.
Yeah, Azur.
So number 8, so please.
Number 8. Okay.
It must be all successor or outages of a given node in a directory.
Okay, Rahul, बुझ्यो?
अलिकति बुझेन, प्र्याक्टिकली गरौँ न एकचोटि के भने।
प्र्याक्टिकली म भनिदिन्छु, अब इम्प्लिमेन्ट त अहिले गरिदैन हैन।
हुन्छ।
सो
एक्सेस अल सक्सेसर्स,
एक्सेस अल सक्सेसर अफ नोड। सो ए को सक्सेसर नोडहरु के छन्? बी एन्ड सी, right? A को सक्सेसर B हो, B को सक्सेसर C हो. It must be able to access their all successors of a given node or all outage. So successor भनेको outage नै हो, right? Outage को mechanism छ भने it is, so outage भन्ने टर्म बुझ्नु भएको छ, of a given node in a directed graph, त्यही नै भनेको छ। ठीक छ?
त्यो बुझ्यो, तर एक्सेस भने कस्तो हो?
कुन चाहिँ?
एक्सेस भनेको सो अल सक्सेसर अर आउटेजेस चाहिँ एक्सेस भनेछ नि त, सो त्यो भन्न खोजेको चाहिँ के भन्नु?
अल आउटेजेस भनेको
हैन, सक्सेसर अर आउटेजेस भने बुझे हैन, तर इट मस्ट बी पोसिबल टु एक्सेस अल सक्सेसर्स अर अल आउटेजेस। तपाईको
जुन प्रोग्राम कोड गर्नुहुन्छ, जुन तपाईले सल्युसन दिनुहुन्छ है, त्यो सल्युसनले चाहिँ इट मस्ट इनेबल, तपाईको एउटा ए भन्ने नोड सपोज छ भने हैन, व्हाट इज इट सक्सेसर भन्ने तपाईले चाहिँ रिटर्न पाउनु पर्ने हुन्छ भनेर यो रिक्वायरमेन्टले भनेको मात्रै हो। Okay, so these are the possible different operations that you might be able to, you might be needed to do, right? Okay, so यो भन्दा भन्दै चाहिँ जब म यो डिस्कस गर्छु contract, I'll also pitch this question to all of you. ग्राफ एडिटी लाई चाहिँ कसरी इम्प्लिमेन्ट गर्ने होला? अब यो डेटा स्ट्रक्चरलाई नै कसरी इम्प्लिमेन्ट गर्ने होला? Do you make use of arrays? Do you make use of stack queues? Do you make use of linked list? Do you make use of binary search tree? Do you make use of binary tree? कसरी गरिन्छ होला? Keep that question on the back of your head. एकछिन चाहिँ त्यो keep that question on the back of your head while we just हामी सर्फेसली मात्र जान्छ यो कन्ट्र्याक्टमा. It has no codes, but then only मेथडहरुको नाम राखिएको छ. Each graph object is a directed or undirected graph whose elements and edge attributes are arbitrary objects. Yeah, accessors basically to count the size, to degree. त्यही जुन हाम्रो कन्ट्र्याक्टलाई इम्प्लिमेन्ट गरेको छ, the contract has been implemented here. The size is of a type integer, returns the number of nodes in this graph. This one here, it returns the number of edges connecting node in this graph. And then this has कतिवटा edge छ, contains edge or not भन्ने कुरा पनि it returns it. Okay, returns different values for connecting edges, for different types of edges here. Made use of transformers. It has made use of transformers, and then transformers in that it clears the graph, it adds new node to the graph, it adds another edge to the graph, similar to what you just saw the time, similar to what you just read for the 2 minutes. When you read about the requirements, each and every requirement from 1 through 8, and then it adds this one adds edges, remove node, remove edge. These are the implementation sign. These are just basic name, and the input it takes your values or the references it takes here. Something to iterate through the nodes, iterate something to iterate through the edges, iterate through the neighbors, and iterate through the connecting edges. These are the functions that does them. So basically the constructors inner interface node define गरेको छ कसरी सेट हुन्छ एलिमेन्टहरु त्यसमा it has defined those here, and then inner edges are for graph inner interface for graph edges continued from that एजहरुलाई डिफाइन गरेको छ एट्रिब्युटहरु कसरी लिने सेट एट्रिब्युटहरु सेट कसरी गर्ने भनेर for the edges. This one was for the nodes, this one is for the edges. So according to your contract, so directed graph को चाहिँ त्यो 8 नम्बर को point को contract चाहिँ digraph भन्ने एउटा directed graph extends एउटा object बनाइएको छ of the existing template existing class अनि it has use this out degree or integer return type function which takes in the graph node and returns the number of out edges of a node in this graph. So basically these are just some functions. There is no implementation here. Java ko code pani chaina, but these they just do some kind of they just fulfill the requirements in the contract that you saw in this slide here, slide 10 and 11 at 10 and 11. So back to the question that I pitched to you. तपाईहरुले ग्राफ कसरी इम्प्लिमेन्ट गर्नुपर्छ भनेर चाहिँ कसरी ग्राफ इम्प्लिमेन्ट गरिन्छ होला, what data structure we might make use of. So please unmute your mic, don't make me call your names. Any ideas that have come to your head, maybe array बाट गर्न सकिन्छ सर, array मा यसरी गर्ने भनेर. Let's just discuss it for the next 5 minutes. I had 2 consecutive classes, so I'm kind of tired. So 3 consecutive classes actually. I had 2 classes for P1 today in the morning. So anyone can you have some visualization of any data structure that we've learned so far that we might make use of to implement graph? array बाट गर्न सकिन्छ भन्नु होला, क्यू बाट गर्न सकिन्छ भन्नु होला, स्ट्याक बाट गर्न सकिन्छ भन्नु होला, अरु सर बाइनरी ट्री बाइनरी सर्च ट्री बाट गर्न सकिन्छ होला भन्नु. So what do you guys say?
Linked list. Hello. Sir.
Hello. Yes, Rahul.
So we cannot hear you.
Really sorry. How long was that for? कसैले केही पनि भन्नु भएन.
9:54. What is?
Oh no.
Mic mute थियो तपाईको.
म त तपाईले बोल्दै हुनुहुन्थ्यो अनि सुनिरहेको छ जस्तो लाग्यो हैन. कसैले पनि केही पनि भन्नु भएन. सरी क्लास. But you had to inform me त्यति लामो टाइमसम्म. So basically what I told over the 3 minutes was that विशाल तपाईले भन्नुभएको थियो लिङ्क लिस्ट युज गर्नु छ भनेर. सो एज र भर्टिसेसलाई कसरी कन्सिडर गर्नुहुन्छ आफ्नो लिङ्क लिस्टमा इफ यु आर इम्प्लिमेन्टिङ द्याट?
पोइन्टर्सहरूलाई चाहिँ एजहरू कन्सिडर गरेर अनि इलिमेन्टलाई चाहिँ नेमहरू नै कन्सिडर गर्ने.
तर फेरि पोइन्टर्समा त एड्रेस हुनु पर्यो नि त. एजको चाहिँ आफ्नो एट्रिब्युट हुन्छ फेरि. जस्तै तपाईँको रोड नेटवर्कमा त्यसको एजको चाहिँ डिस्टेन्स थियो होला भने त्यो चाहिँ कसरी कन्सिडर गर्नुहुन्छ? गुड पोइन्ट है, तपाईँले पोइन्टर्समा युज गर्ने भन्नुभएको छ. बट पोइन्टर्स आर फर एड्रेस नट फर डेटा नोट्स है. एजेसहरूको आफ्नो नाम हुनसक्छ. त्यो केसमा चाहिँ के गर्नुहुन्छ? Rahul, when's the next class?
10:30.
Okay, I might take 2 minutes more. So 2 minutes extra. So to cover up for the things that I spoke one way and then I didn't know that it was on mute on my phone. I'm using my phone so that this audio thing is clear. And no one informed. Thank you for that, Rahul, for the information. So about I typed in this example here, right? There was the name of so let's say that it's a database containing your student name, first name, last name, blood group, and all of that. So if it is so the database के लाई चाहिँ तपाईले फाइलमा पनि रिप्रेजेन्ट गर्न सक्नुहुन्छ. So let's say that एउटा कसरी डिफाइन गरौँ भने डबल ह्याशले फर्स्टमा आएको आइटम फर्स्ट नेम हुन्छ, डबल ह्याश पछि आएको नेम चाहिँ तपाईँको लास्ट नेम हुन्छ भनेर डिफाइन गर्न सकिन्छ. अनि त्यस पछाडि फेरि त्यसपछि आएको चाहिँ फोन नम्बर हुन्छ भनेर डिफाइन गर्न सकिन्छ. अनि त्यसपछि आएको चाहिँ तपाईँको ब्लड ग्रुप हुन्छ भनेर. बट सी द कम्प्लेक्सिटी हियर. अब फेरि यसलाई एक्सेस गर्नु पर्यो, Okay, blood group होला. Okay, blood group होला. So यसमा हेरौँ यो यसलाई एक्सट्र्याक्ट गर्नु पर्यो यसबाट फाइल यसबाट लिनु पर्यो भने yes it's possible to represent all in one line but see the complexity here. Complexity पनि हेर्नु पर्यो यसमा राइट. कम्प्लेक्सिटी हेर्नु पर्यो. अब यसबाट लास्ट नेम लिनु पर्यो भने फर्स्टमा त्यो स्ट्रिङलाई लिन्छ. स्ट्रिङले के गर्छ त्यो स्ट्रिङले ह्याससम्म दुईटा ह्याससम्म फाइन्ड गर्छ. त्यसपछि अर्को ह्यास नआएसम्मको क्यारेक्टरलाई उसले तान्छ होइन. तानेर अनि बल्ल प्रिन्ट गर्नु पर्यो. To see the complexity here. So data structure, हामी पढ्छौँ data structure. We do different kind of solutions to in computing overall, but it should be the least complex and it should be the simplest. So one of the simplest way to represent a graph is to store a set of nodes and a set of edges. Okay, so store a set of nodes and a set of edges. So उहाँले अघि भन्नुभएको थियो विशालले पोइन्टरमा राख्ने भनेर एजलाई बट द्याट वाज नट कम्प्लिटली एक्युरेट है. तर मेबी यु कुड डु इट बाई समथिङ एज सच नोड्स र एजहरू दुईटा डिफ्रेन्ट सेटमा राख्न सक्नुहुन्छ. एन्ड विल सी इट. सो दिस वे अफ रिप्रेजेन्टिङ दिस एज एन्ड नोड इन सेट्स इट्स कल्ड एज edge set representation. Represent both the node set and the edge set using a doubly linked list. Linked list मा चाहिँ doubly linked list. विशाल was not far from accurate, but उहाँको चाहिँ त्यो edge र node लाई चाहिँ consider गर्ने कुरा चाहिँ त्यो नभए पनि doubly linked list चाहिँ उहाँले मिलाउनु भएको थियो. Use DLL to improve the time complexity of the deletion operation भनेर भनिएको छ. What is the time complexity of the deletion operation of DLL? It is of a constant order, right? It is of a constant order. If you remember, I won't go to the other slide. We are out of time. So I'll leave you with this. You hearनुहोस् तपाईहरुले. I'll leave you with this. The next class that we are going to have, we'll be discussing this. This is the graph. The alphabet on the uppercase are the nodes, the elements of nodes, and the lowercase are the attribute of the edges. Those are the attribute of the edges. So doubly linked list use गरिएको छ. र एकातिर चाहिँ तपाईको एजेसलाई राखिएको छ, अर्कोतिर it has made use of, it has stored the elements of the different nodes. So and then it's quite अघि पनि मैले क्लासमा 10 मिनेट डिस्कस गरे P1 मा, but then we did not we discussed it for 10 minutes, but then we came to this right here. Please take a screenshot and please try to make sense of this. We'll discuss it in tomorrow's class. Okay, everyone, I request you to take the screenshot, or maybe CR, Rahul, you could take a screenshot and post it on the chat. That would be convenient. But everyone, please, you around, say, Boli, how, and then we'll discuss the edge set representation. I actually finished this in that previous class 20 minutes back, but we discussed attendance. We'll discuss your attendance soon. So yeah, that's it from the today's class. You have a break, enjoy your break. I have a good day ahead. We'll discuss if there's anything on the next class. All right, class. I would like to request you to leave. I'll stop the recording first.
Okay, sir.
I'll stop the recording first. And Rahul, if there's nothing, I'd like to end the class.